Hey everybody, this is Mr. Wyrick and I'm here to talk to you about 3.14 arc lengths and sector areas. This is actually kind of a complicated delta math, not a super complicated topic, so you're gonna have to kind of pay attention through these notes. Otherwise you're gonna get the delta math way of explaining things, which is not great. Okay, so slide number 2 here talks about finding the area of a sector of a circle. So yesterday, or Thursday, however you want to think of it, you were working on finding the area of a circle. So that's right here, its area is equal to pi r squared. So when you want to find the area of a sector of a circle like this, how big was the piece of pizza that you just ate? You find the area of the entire circle, and then you're just going to multiply that by the portion of the circle that you have. So if this is a 60-degree angle, we're multiplying by 60 out of 360, or if you can reduce fractions, you're multiplying by 1/6. Okay, so we're going to find that area, we're going to multiply it by the proportion. That's going to give us the area of just our sector. So if we look at this one, solve the following problem, express in terms of pi, then round to the nearest hundredth. You noticed on yesterday's assignment, there was both put your answer in terms of pi and then round your answer depending on which section you were doing. So on this one, this is 10 inches. So if we're doing the area of the entire circle, that's 10 squared times pi, so 100 pi. So that would be, again, we're multiplying by 60 out of 360. That would reduce down to 1/6. So this is going to be 100 over 6 pi. And it should be square inches. And we could, of course, divide that out. 100 over 6, of course, we can reduce to 50 over 3. On this other one, we have 3 meters. 3 squared is 9, so that would be 9 pi. And then we're multiplying that by 150 over 360, which is 15 over 36, which is 5 over 12. So that's 45 over 12, or 9 over 4, and it would be pi. Okay, again, it's just kind of reducing that fraction down or letting Desmos kind of do that. Length of an arc, remember, we're not talking about the degrees anymore when we're talking about length of an arc. This is why we're finding circumference. You find circumference, which is 2 pi r, and then we're going to multiply that by the angle in the same way that we did for area. So with this one, it would be 22 pi times 315 over 360. This would be 26 pi times 270 out of 360, okay? Your assignment is in delta math. The delta math, I just want to show you real fast. Let's edit the assignment, and it's 321 circumference and area. Oh, not circumference and area from 321. Let's go back. This is the 322, sector area and arc length. When we look at the skills, it's just arc length versus sector area. There's only 10 of these, but it gives you the area and then asks you to find the length of the arc. So you're going to have to convert back from this to find just the radius, okay? And then once you have the radius, oh no, it already gives us the radius. So you convert back from this to find the angle that you had in terms of pi, going backwards, and then just, subtract from 360 to get that distance around there, multiply by that one with your radius, okay? So again, the whole thing would be 4 pi. So the fact that we're at 5/3, we had to multiply by something to get there. So it's 4 times x equals 5/3. That'd be 12 is equal to 5. So it's 5/12 of the circle, which would be, I think 150 degrees. So if this is 150 degrees, then this is the rest of that 360. So 360 minus 150 should be 210. So this would be, you would take 4 pi times 210 out of 360 to get your answer, okay? And you're gonna put it in terms of pi, so you don't have to do the extra math there. This is gonna go back and forth between, I think, in terms of pi. No, it's all gonna be in terms of pi, so you should be able to work through this just fine. If you're struggling with it, just remember you can ask questions of me when I see you back in class on Monday. Good luck on the assignment. Have a great weekend.